This is question 3 of the Multivariable Regressions chapter of the Regression Models book. It refers to question 1 and 2, so make sure to watch those videos first. Take the residuals for drivers killed having regressed out kilometers and an intercept, and the residual for petrol price having regressed out kilometers and an intercept. Fit a regression through the origin of the two residuals and show that it's the same as your coefficient obtained in question 1. I'm going to do a couple of things to make this a little bit easier so I don't have to type so much. So I'm going to just, drivers killed is DK, and it's going to be seatbelts, $, drivers killed. Okay, so let's just make sure we got it correctly. Okay, and then KMS is just going to be seatbelt star KMS. That one's easy. Seatbelts. And then petrol price, I'm just going to do lowercase pp, and that's seatbelts, $, petrol price. Okay, so the full fit, let's call that fit 0, is going to be, or let's just, so we remember, fit full, it's going to be the linear model, drivers killed as the outcome, kilometers, and petrol price as predictors. Okay, so let's leave that one for the time being. And then let's regress kilometers out of, so let's call the residual for drivers killed is going to be the residual for the linear model that takes drivers killed and fits kilometers. Okay? Now this automatically includes an intercept. Okay? And the residual for petrol price is going to be the resid for the linear model that has petrol price as the outcome and kilometers as the predictor. Okay, so now in these two residuals, we've regressed out any linear association with kilometers from both drivers killed and petrol price. Now the claim is that if I fit so let's do summary of a linear model that takes the residual of drivers killed and looks at the petrol price residual and does regression through the origin. And let me just grab the coefficient table. Okay, that's the estimate, the standard error, the t-value, and the p-value associated with the petrol price residual as a predictor and the residual drivers killed as the outcome. Now let's look at summary. Remember, fit 0 or fit full was our full model fit where we had drivers killed as the outcome, kilometers in as a predictor, and petrol prices in a predictor plus an intercept, and let's see what we get there. Now if you look at this quantity right here, right, that is identical to this row right here. Okay, and you can see maybe there's a little rounding error, but the estimate is identical, and the t-value is fairly close, and the p-value is fairly close. But the estimate is guaranteed to be identical. The reason for this, and this helps us explain what adjustment is doing, one way that we can think about the estimate, is that the way regression accomplishes adjustment is to remove the linear association of the variable, of the nuisance variable, in this case kilometers, to remove its impact on everything, the outcome and all the other regressors. And the way we think of removing that effect is in taking residuals. And then once that's been removed, then fitting a regression model with just the residuals. And so that's the way we can think about how regression models do adjustment. Conversely, it's also true that the coefficient for kilometers, this one, we could get that exactly by taking the residuals, having taken regressed out petrol price from both the kilometers variable and the drivers killed, the outcome variable.